Hello, everyone. It's Brandon. Welcome to Steelbridge's very first MASTAN tutorial video. Our intention with these videos are just to give you guys a resource instead of the PowerPoints. We're going to be doing these instead of going through the basic MASTAN and Fusion information in the G bodies, just to move the design process along. So you'll have access to these videos along with the PowerPoints we're based on. And yeah, I think it'll be helpful while you're working on it. You can come back to the video and work along with me, and hopefully it helps. So I'll share my screen. And good. Okay, so here is the bridge we're going to be making. Just a quick walkthrough of it. Some ground rules before we start. Some MASTAN ground rules. Make sure you save a lot because MASTAN, there's no undo button. If you mess up and you didn't save for a while with your work, sorry, because it's MASTAN, and yes, it's very frustrating, but just to prevent that, save as much as you can. It can also crash a lot. So if it crashes and you didn't save, you lose all your work. It happened to me last year. It's very unfortunate. So we can prevent that though by saving as much as you can. Another thing, MASTAN is unitless. So we'll often be working in pounds and inches. So since it's unitless, you kind of decide what units you use, whether it's centimeters, pounds, for newtons, inches, whatever. You decide what you use. Just you have to be consistent, and it's better to use pounds and inches because that's what we will be trying to use as a team. So then when we collaborate, it's a lot easier to work with another if we have the same units. So make sure you're consistent with the units. Yeah, and I think we're good to start then. I'm gonna save this, and we can start a new one. It'll ask. Make sure you save when you see this. And yeah. Okay, so first, when we're building our structure, we have to start with some nodes. We can go on geometry, define nodes. We can start the origin, 0 in the X, 0 in the Y, and 0 in the Z. As you can see here, we have the origin. There's a point. Let me fix my view. These are very helpful too, labels. We can label our nodes and our elements. See, now that I turn that on, you can see N1, that means first node. I only had it off before, so my view looked better for the structure, but by default will be on. And then we can make our second node at 72 inches. So 72x, 0 for y, 0 for z, and apply. And there we have two nodes. We can connect those nodes by making an element, find it in geometry, define element. You can click first node, which will turn pink. That's how you know when you selected something. It'll turn pink. And second node, now that's pink. Node I, node J, those are the two nodes you'll be connecting with this element. Click apply, and there's your element E1. There's another way to do this that I discovered last year from the design leads. Very helpful, I think, when you're doing a lot of nodes and a lot of elements. So let me delete these first. You can delete your nodes and delete your elements through geometry. First, you have to remove the elements before you can remove nodes, though. So remove element, click it. It's pink. Again, that's how you know it's selected in MASTAN. And element 1 is selected. Apply. That removes it. And then we can remove our nodes. We can select them both at the same time. Pink for both of them. And apply. And now the other way that we could do this, the alternate way, is using geometry and going on input geometry. And what we can do here is when we're defining our nodes, you do the x coordinate, the y coordinate, the z coordinate, same thing as before, but you can type it in yourself. So 0, 0, 0. Make sure you use a space separating each character. And There's our first node at the origin, like we said before. And then we did 72 inches. So 72, 0, 0. Apply. And there's our second node at 72 inches again. And then on this bottom left drop-down menu, you can select the elements. And now this, the notation is first node, second node, and beta, which is in degrees. It's just the angle. We leave that as 0. So you're gonna do your first node number, second node number, 0. When you do it like this, first node is node 1, second node is node 2, and 0. And click apply, and it makes an element. And yeah, so another tool in geometry. Geometry is where you'll find all the node tools and all the element tools. They're very helpful when you have a lot of nodes and a lot of elements. So we're just going to go through some. We can scale nodes. So let's say we want to double the span of this member right now. What we can do is select node 2, see how it turns pink, and we can do it about the origin, with respect to the origin. So that's 0, 0, 0. And if we want to double it in the x direction, we can do 2 for cx, and we don't want to scale it in the y or z direction, so we can keep those inputs as 1, and click apply, and that's doubled. And a way for you to know that, another very helpful tool in geometry is the information. We want some node information with this, so click node, and we can select which node we want to look at. Node 2 is at 144. We doubled it from 72 to 144, so we know that the scaling tool worked. Another helpful tool in geometry that we can use a lot is subdividing elements. Let's say you have one member like we do here, but you want to divide it into equal lengths, and not have to make all the separate nodes by yourself, because it's kind of a pain to do the calculation and then make a node. And also, let's say I want to define a node on this element, let's say at 36 inches. It might appear like it's on this element, element 1, but it's really not. What you need to do in this situation is remove element 1, and you would need to make one element from 1 to 3, and make an element from 3 to 2. So when you're working with a lot of nodes and a lot of elements, that can be a pain. And if you don't fix it like I just did and just have the one element, then node 3 will be what we call a loose node. It won't be attached to the structure. So when you try to do like your structural analysis, it's going to fail. So to avoid all of that, let me get back to where we were. Removing these 2 elements. See, it's pink. That's how we know which ones we're selecting again. And let me remove this node. Remove nodes. And let me define an element again. Node 1 to node 2. Okay, so now we're back where we were. So to make this so much easier and to cut out basically everything that I just said, you can use the subdivide tool. And that's in geometry, subdivide elements. And let's say we want to take element 1 and divide it into 4 equal length segments. We select it, make this 4, apply. Down here in this bar, that's how you always see when you press apply, you can check this bar down here on the right. And that's how you know that something went through. If it says success, if it says fail, you have to check and see what went wrong, but success. And now MASTAN created the nodes by itself and the elements too. So first element from 1 to 3, second from 3 to 4, third from 4 to 5, and the fourth element from 5 to 2. So clearly compared to just the 2 elements that I made before for just one node on that member, this was a lot quicker and it's a lot more efficient, especially when you're working with a whole 3D structure. So subdividing, very important. That's how you do it. And another tool we can go over in geometry is duplicating. Let's start building at another height. Because we want to make a truss, right? So let's select these 3 nodes, 3, 4, and 5, and let's duplicate them 36 inches upwards. Because we want that top horizontal chord of our truss. So I selected them, delta Y. These delta boxes, the number you put in them is the amount of distance they're moving. Make sure you note that the Y is upwards, the X is to the right, and Z is pointing out of the page. And so when you want to move something in those directions, put a positive value in here. But if you want to move something in the opposite directions, of course, you put the negatives. So we want them to be vertically upwards. So positive 36, and we click apply, and there you go. And now we can start attaching these nodes to one another using define element, or we can do the alternate method that I said before, and I'm going to do that. So 1 to 6, 0 for the beta value. Oh, don't do what I just did. That was wrong. Make sure that when you do input geometry, you select that drop-down menu on the bottom left. So input geometry. Don't forget to change this. Don't do what I just did. 1, 6, 0. Now 6, 7, 0. 7, 8, 0. And 8, 2, 0. There's the outline of our truss. Now the actual triangular trussing within it, we can do 6 to 3. 6 to 4. 4 to 8. And 8 to 5. And 7 to 4. Okay. Now I'm going to save because I told you guys before how important it is to save and I still haven't done it. So I'm going to save. Again, it's important to keep saving. When you do save, try to use some sort of naming convention. Depending on, like, for example, you'll change your section properties when you're trying to optimize it. So when you're naming your save files, make sure to save all of them. Even if it doesn't give the best results, you want to save every single file you have and come up with some sort of convention for naming them, usually by the section properties. But I'm just gonna video right on. The one I had before was the first one, so the second one. And yeah, so now obviously for design team, we're not gonna be designing something for 2D. We have to make it 3D, and we can do that using the duplicate nodes feature again that we just did before. And we can do that here in geometry. So we want to move it in the Z direction, right? So we can move it 12 inches in the X direction, 24 inches in the Z direction to translate it. And of course, this is going to go to the right and out of the page. And make sure when you're doing so, you click all nodes. This button, instead of having to go through every single node, you click all, and it's going to highlight them all pink for you, so you can make sure, and then click apply. And then you also have to do for this, we didn't do this before when we were duplicating, but now we're fortunate enough that we can just duplicate the elements with those nodes. So click all again, see it's all pink, and move it the same translation, 12 inches in the X direction, positive X direction, 24 inches in the positive Z direction. And click apply. And there you go. It doesn't look so pretty though. So we have to get this glare out of my room. We have to fix our view. So MASTAN has this view tab up here. There is a bunch of different views that are actually very useful. Because sometimes you want to look at in the XY plane like we are now, that's the front view. Sometimes you want to look from the side, the YZ. Sometimes you want to the top view, that's XZ. Here we can see how we moved it 12 inches in the X direction and 24 in the Z direction. Or this view is the 3D view, the isometric view, and the XYZ plane. And there you go. You can turn off your labels to see it clearer because there's kind of a lot going on. And see it's 3D now. Here is the first truss, and we translated it. Here's a second one. But we need to connect them, of course. We can't just have two planar ones. We want a 3D structure. So we can do that by defining the elements. I'm going to turn my labels back on so it's easier to follow. Which elements are there to account for all of them. And we're going to connect these bottom ones here. 9 and 1, 11 and 3, 12 and 4, 13 and 5, and 10 to 2. There we go. And then 14, hard to see up here. That's when you would maybe take away the element label so you can see all the nodes up here. You're connecting them. 14 to 6, 15 to 7, and 16 to 8. Okay. Sometimes like when I was just doing that, it can be very hard to actually see all the nodes and see if they're attached. A really good way to check if all your nodes are attached is to go to remove nodes, all unattached. If there are nodes that are not attached, like before I call them loose nodes, if you click this button, they would highlight. Nothing's highlighting. So that's how you know that all your stuff is attached, all your nodes are attached. And it's very helpful when you're doing your analysis and it's failing and you're not sure why. Sometimes it's because you added a node and it's not attached to anything. So using this tool, the remove nodes, and selecting all the nodes that are not attached, it comes in handy. Okay, I'm gonna save. And then we can move on to properties. We have to define our section and the material that we'll be using. So first we can do our section. So we're gonna do a 1x1 16 gauge for this example, and make sure to name your section because we'll be keeping track of a lot of them. We'll provide you guys with a sheet, a database of all of the sections that you might want to use in our folder, the design folder for Steel Bridge, and also MASTAN has its own database here. And there's also a feature, the advanced feature. If you go in the drop-down menu, go from basic to advanced, click the MSASect button, let it load, still loading, and rectangular shape. And here we would, you could put in the dimensions of a section and it would calculate all the properties for you. So you have that tool, you have the database, and you have the sheets that we're going to be providing you with for the section properties. We're just going to do this 1x1 16 gauge, and I'm going to use that sheet real quick, pull it up. And the area, IZZ is 0.03559. Oh, I wasn't typing. Make sure you're typing to do it. 125 is good. IYY will be the same thing. And then for J, we'll be using 0.07118. And of course, like I said before, MASTAN is unitless. So these are all they're based off of inches squared, inches cubed, and J is also inches cubed. Make sure you're being consistent, especially based on the nodes you did. And then when you're going to your section properties, make sure that you're being consistent. It can really mess up the numbers, and we don't want that. So we don't need to fill in CW or anything down here. We named it. Everything looks good. Click apply. Now that doesn't attach it, but it's defined now. And we're going to leave that there and go to define material. So of course we'll be using steel. For Young's modulus, we can use 29 times 10 to the 6th power. But MASTAN does not take this input that I'm typing right now. If I were to type times 10 to the 6, it doesn't, you can't use those symbols, just the numbers. So, and you also cannot do 29 like this. You can't use commas. So what you can do, there's a few ways you can still do it though. 29 and 6 zeros. So 1, 2, 3, 4, 5, 6. Or you can do 29E6. You can do 29 lowercase e6. You can do 2.9 capital E7, 2.9 lowercase e7. Those all work. You just cannot have a comma for 29 million, and you cannot do the multiplication symbol times 10 to the 6th power. You can't do that. MASTAN doesn't take that input. So I will do 29 and 1, 2, 3, 4, 5, 6. Poisson's ratio is good, and the weight density 0.283 pounds per inch cubed. Again, we're staying consistent. We're using pounds and inches. Apply, and that material is defined, not yet attached to our structure. So we can attach it by going on properties, attach section, click all, because currently for this video, we're going to be using this section for every single member on this structure. When we're maybe doing some optimization, we'll be using different sections for different members. But for now, we can click all, make sure it's using section 1. We can check, this is what we named it. These are the properties we gave it. Looking good. And apply. Now you can see the dotted lines got separated more. That's how you know that the section was attached to your structure. And then we can attach the material too. So again, click all. You can check here. It's the first material we defined, and it's named steel, and these are the properties we gave it. So all good, and then click apply. And you know that went through because now the lines are solid. So looking good. Okay. And then we can define fixities now. Of course, we're gonna have certain connections on the ends of our bridge, fixed, pin, roller. So it's gonna be constrained in certain directions in displacement. So on the bottom left, it's going to be fixed in the X, Y, and Z displacements. And when that happens, you'll see an arrow pointing in the X, and the Z, and in the Y. Same thing here. And then we also want to, on the bottom right, node 2 and node 10. Now, what I'm doing here is fixing it in the Y direction, but be careful because as you can see, these nodes are still pink. So they're still selected. And you can even see here, it says 1, 9, 2, 10. So before you even select two different nodes for different fixities, you want to clear. So now those aren't pink. And 2 and 10 displaced, fixed in the Y displacement, and click apply. And now these are good. If we hadn't, for example, if we did this, then they're all applied. And then if I click up, they're all selected. If I click apply now, they're all in the Y direction, and then our bridge isn't stable, so it's going to fail. So make sure that you clear afterwards, like so, and then let's fix this back to how it was in X, Y, and Z. So now we're good. What do you want to do from here? So now we basically have our structure. So finally, the next thing we can do is we can start applying a load to the structure. Of course, in the competition, there will be loads applied. And we can do so by going on conditions. You can define a uniform load. And let's put it across these horizontal chords. And very important, of course, the forces here, the distributed load is going to be acting downwards. So like I said before, the coordinate system, Y positive, it's upwards. So if we want this force to act downwards on the structure, we put a negative, we can do negative 20 pounds per inch. And it's on these chords here, they're selected, they're pink. That's how we know. And apply. And that's how you know when you see something in green, that's a load. That's the distributed load that we have, and it's across, it's distributed across these horizontal chords, 20 pounds per inch. And now that we have that, let's save, because I haven't saved in a bit. We can conduct the analysis to see if our structure is stable. And then once we finish the analysis, then we can go on results and look at the displacements, the reactions, the weight, everything. So analysis of the static first order elastic analysis. Very important. We're working in 3D, of course, right? So MASTAN made an assumption, and they're actually correct. We have to do a space frame analysis. We can't do planar frame or planar truss, because those are 2D. You see, it's only in the XY plane. So we're doing a space frame analysis. Click apply. And that means our structure is stable under this load. Sometimes it'll say fail. Again, some troubleshooting. You would go to remove nodes, all unattached. If things get highlighted pink, then you know that you forgot to attach a node somewhere. Make sure that all your section properties, they're defined. Your IYY and your J, for all your elements, including the 3D ones. Make sure that the material and your sections, that they are attached to all your elements. You may have put brand new ones in and you forgot to attach them. So make sure that they are attached. Make sure you have diagonals and supports when we're connecting the nodes to one another. Make sure you have those, because if some nodes aren't connected in the proper way, then the structure will fail. And if you're still confused in the end, just ask for help. That's the most important thing, whether it's in your work group or it's us, the design leads. Like, we're here to help you, so make sure you ask for help. We'd be glad to. And then, because we finished our analysis, we can go on results. We can look at the deflected shape of this. So the whole thing is selected. So we're going to see the deflected shape for the entire structure. Apply. There it is in blue. Another thing we can do is look at the node displacements. This is very important because when we get the rules and everything, we're gonna have to apply certain loads at certain nodes. Sometimes you even have to put an additional node in for where that load will be applied when we're at the competition in the spring. So you can choose results, node reactions, and select a node. and see the force that the reaction being received at that node in the X, Y, and Z. And this is in the X, Y, and Z because we fixed it before in those directions with the fixity. And so like if you take the sum of all the FYs here at your nodes in the corners that we define the fixities at, the sum of them is the weight of your structure. So that's very important too when we're doing our optimization. We can also look at the node displacements because, of course, we don't want our nodes to displace too much. So at node 12 here, for example, it's displacing negative 0.03609 inches in the Y direction. So that's a very helpful tool as well. Let me save again. And then this is more for later in the semester, but when we do optimize everything, some things to keep in mind. Consider section properties, the size, the shape, and the thickness of your members, your truss design, making small changes, whether it's like changing the section you're attaching to the diagonals as opposed to the other members in your bridge, and your loading cases we'll supply you with, like I said before, in a spreadsheet, so you know where exactly to apply loads, and the load to apply, as well as the shear force as well that we'll be applying. And then we're also gonna supply you guys with the cost calculator in the design folder. So in doing so, you can plug in the weight and you can try to minimize the cost of the structure. That's very important as well. And while you're making your structure too, that's more for the later things. But you want to keep in mind, we're trying to make it easier on the fabrication team, the construction team, the welding team. So keep them in mind to design a structure that isn't way too crazy to fabricate or weld, because some things just won't be possible. We can't just make anything. There are certain limitations, so we have to work together with them and keep that in mind. And we'll supply you with all the structural efficiency tools as well in the design folder. Yeah, and again, when in doubt, you should ask us for help. Like, we're here to help. We're glad to help. Come to this video again if you are stuck, and if not, you can ask us for help. We're always here. So yeah, I think that's about it. I hope everything went well. Hope this was very helpful for you guys. And I hope you guys have a good one.